imaginary part. So in this question, this is x, this is y. So if you find the real part of this number, the real part of this number
It's -4.
-4.
Yes.
It's not -4, but two of you, your answer is not right. It's -4. Okay? So the second question, the imaginary part of this one. This is x, this is y. Y is imaginary. So the answer is
-6.
imaginary, not real. 7, yes, 7. Okay, this is x, this is y. Y is the imaginary. Okay?
But that -6 has I.
Oh, I'm sorry. Yeah. Yes. Yes. You need to write 7 minus 6i. Listen up. So this is x, this is y. So the answer is -6. Yes. -6. This is the second. The third one. If z equal x plus iy, we say the modulus of z is this one. Okay? So in this question, the modulus of -6 plus 8i equal root of 36 plus 64. So it's 10. You check your answer is right or not. It's 4. I mean it's 10. This is 10. Okay? Understand that?
Yes.
Okay? This one. If you want to obtain all the argument of z, you need to obtain the principal argument of z first, then plus 2k pi. Yes or no? Do you remember the principal argument of z? We can obtain a formula. The first one, if z belongs to the first and the fourth continent, you can write arc tangent y above x. If z belongs to second, you can write arc tangent y above x plus pi. If z belongs to third, you can write arc tangent y above x minus pi. So now, if z belongs to here, the principal argument of z is 0. If z belongs to here, the principal of argument z is pi above 2. If z belongs to here, is pi. If z belongs to here, is minus pi above 2. So let me see this one and this one. Okay? If you want to do this one, first you can do this one. Yes or no? Then plus 2k pi. Okay? This is -4, this is -7. Which continent? -4. -4 is here. -7 is here. So the third one. So we use this formula. Okay? So you can write then plus 2k pi. This is the last answer. And k, you can write 0. And so on. So please check your answer. Your answer is right or no? Right.
Yes.
Any question? Or understand? Okay. This one. Here is b. So you need plus 2k pi. If here is small, so here no 2k pi. Only use this formula is okay. So x is minus 2. Y is 6. X is minus 2. Y is 6. So in this continent. It's not in this continent. In this continent, we can use this formula. Use this formula. So you can write arc tangent. Y is 6. X is minus 2. It's not? Then plus pi. You can also write pi minus arc tangent 3. So this is the last answer. This is the last answer. You are right? Yes. Yes. Okay. Okay. The last one. This one. This one. If you want to compute this one. Okay, you know, if you write like this, this is too difficult. So we need to write 2 plus 3r into exponential form. Do you remember? Yeah. If z equal x plus iy, we know the modulus of z, we can write r. The principal argument of z, you can write theta. Yes or no? So, this z, you can write r cosine theta plus I sin theta. Yes or no? So, using Euler formula, this part we can write E I theta. Yes or no? So, if you have this knowledge, we know this x is 2, this y is 3. So 2 plus 3r. We can write the modulus of is root of 13. Yeah. Theta is one of the argument is okay. One of the argument of z. So we often write the principal argument of z. The principal argument of z, we know this is the first continent. So we can write arc tangent y above x. Okay? So 2 plus 3i. We can write this is r, e, I, this is theta. Yeah. So if you compute this one, not write like this, but write like this. So here is understood. E I arc tangent. Then 10 power. 10 power. Isn't it? 10 power. So the last answer. The last answer we can write here is okay. Here is yes. So this is the last answer. Understand it? Okay, if all of you understand it, we teach new knowledge. Can I erase them? Okay, or erase. Okay? Just now we know. Okay, this is the algebra form. This is the triangular form. This is the exponential form. Okay, so if they like this one, if we want to obtain the m power, it's very easy. Equal r e I theta m power. So equal r m power e I and theta. So now, but now if we don't write like this, if we write like this, this is the power, this is the root. Okay? If you want to find the nth root of z, how to compute? We can also write z is REIC. Okay, but equal what? Maybe you will say equal this one multiply this one. Because you will say you can write this like this. So now, if you write like this, okay? Okay? Yeah. But this is not right. Why? Do you know why? Why this is not right? Because it's like a power.
Because power is a fraction.
Because power is a function. This is not a function. This is also a function. Because this theta only one of the argument of z. But this theta is not unique. Yes or no? Yes. For example, if z 1 plus I, you can write, okay? You can also write okay? So this theta, you can take pi about 4. You can also take 9 pi about 4. And you can also take e plus 2k pi. Okay? So this theta is not unique. This theta can take any argument of this one. So here you can take 0 and 0, 1. So there are many values of theta. Many values of theta. So if this is wrong, which is right? Which is right? So please follow me. Okay, follow me. Which is right? If we want to obtain this one, we can take this one equal omega. So we know if the root of z equal omega, so we can obtain z equal omega and power. Yes or no? If we want to obtain the formula of this one, you only obtain the formula of omega. If you want to find omega, you can from this equation. You can from this equation. In this equation, z you know, omega you don't know. You only know of z but not know omega. So from this equation, how to find omega? You can let omega equal rho ei phi. Rho is the modulus of omega. Phi is one of argument of omega. If you can find rho and phi, then omega you find. If you find omega, then you find this one. So we put this omega into this equation. Z equal REI theta. Omega, you let rho ei phi. Here is n power. And in this right side, we know, using this formula, this one equal rho and power EI and phi. Okay, so this one and this one equal this number equal this number. Is no, these two numbers equal. If these two numbers equal, this R is the modulus of Z. This rho and power is the modulus of this number. If this number and this number equal, the modulus of this number equal the modulus of this number. So we can obtain R equal rho and power. Any question here? Do you understand it? You want to sleep?
No.
No.
You understand?
Huh? What's wrong with you? Why you can understand it? Okay, let me finish it. Okay, this is the first equation. The second equation is EI theta equal EI and phi. I say, if this number equal this number, R is the modulus of this one. Rho and power. Rho and power is the modulus of this number. Okay? If this is Z1, this is Z2, you know, if Z1 equals Z2, the modulus of Z1 must equal the modulus of Z2. Is it not?
Yes.
So, this one is satisfied. Okay, if this one and this one equal, so this one equal this one. The second satisfied. Do you understand it?
Yes.
So if this one equals this one, we can obtain these two equations. These two equations.
Okay. You mean if they are equal to mean that n can have to be 1. If they are this way, this will have to be 1.
Yeah, we can obtain. If this one equals this one, so we can obtain 5. Okay, continue. Do you understand this one?
Yes.
If n can be 1, I can understand.
Yeah, computer. Okay, okay. From here, R is real. It's a real number. Rho is also real number. So we can obtain rho equal. Okay, you don't.
Oh, yes, 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 yes.
It's not because R and rho is a real number. Real. Okay? But this one equals this one. We can't obtain theta equal and phi. Because
They are not really.
if theta equal and phi, these two will equal. But if these two equal, theta is not equal and phi, but equal theta plus 2k pi. Because,
City is not really.
yeah, if this one equals this one equals this one, this number and this number, we can plus 2k pi. Okay, so if this equals this theta and phi satisfy this. So this n phi equals theta plus 2k pi, but not theta only. You must plus 2k pi. Do you understand it? Yeah, okay? Do you you understand that? Yeah, all of you understand. So we can obtain rho. Is this one? Phi is this one. If rho you know, phi you know, so omega you know. Omega equal rho multiply ei phi. So rho is this one, phi is this one. Okay, and this k is 0. And so on. So there are many values of this omega. Okay, continue. Do you want to sleep?
It's okay now.
All of you want to sleep. I also want to sleep. Because it's too warm.
Yeah,
It's too warm.
Yeah, but
Yeah, if in this classroom it's cold, maybe you don't want to sleep.
it's okay. You won't sleep.
It's not finished. Continue. Okay. There are many values of this omega, but there are also some same values in this one. For example, if k equals 0, this number is theta above n. Okay? But if k equals n, you can see in this one, if k is 0, omega is this one. This is k equals 0. But if k equals n, omega yes or no? But I think these two equal. Do you think so? Do you think so? These two equal? No.
Yes.
Don't equal.
Those are
I think they are equal.
They equal or not? No. Here is n.
This is
Here also n.
is hand.
Is it n?
N.
2 head.
2 and pi.
All 2
K equal n.
Yeah.
Yeah. So I think this one and this one
Yeah,
equal. Yes or no?
Here k equal to 0.
Yeah.
So it's 0. So here k equal to 100.
Yeah. So I want to tell you, k equals 0 and k equal n the same. And k equal 1 and k equal n plus 1 the same. So there are many same values. So this k is not necessary be so many answers. We only take k equals 0, 1, 2, 2 and minus 1 is enough. K is from 0, 2 and minus 1 enough. It's enough. Yeah. So you understand that? Okay. So if omega equals this one, so you know if the nth root of z, we know equal omega. Omega equal this one. So this number equal R. I write here, okay? This is the same. This is the same. You only. Yeah, I take it. Yeah. Plus 2k pi. And this k equal 0, 1, 2, from, yeah, it's enough. Okay, please see carefully. I take some choice. Okay.